In the previous lesson, we saw how we can create 2D graphics in FreeCAD and using the draft interface. So we created some curves and some straight lines, some arcs, some circle. We created also closed shapes. Now, this is intended also to model in 3D. So just as we said in other lessons, FreeCAD main purpose is to create 3D objects rather than working in 2D. But you have a lot of tools that you can use. It's not as user-friendly as could be like AutoCAD or LibreCAD in working in 2D, but you can still use it for 2D drawings, technical drawings, and things like that. But anyway, the primary purpose, the primary function of setting the base in 2D is to use that 2D drawing to do some parametric modeling. Like for example, if I take this hexagon here and then I move into, let's go for example in the part workbench, then we have the possibility to go and use extrude. Don't confuse it with a cube, which is a little bit similar. So if I extrude this, I can say, okay, I want to go like along the normal of this or custom direction, and say I want to go like on the Z, and let's make it like 10, and then let's apply. So you can see now the extruded 3D shape, or we can define this 3D solid because it's a completely closed shape with all the surfaces. So it's a solid that we can use for 3D printing and things like that. So the 2D is just the beginning of something else that will come later on, or it could be just, technical drawings and annotation we can do. Of course, we can help to work in 2D using the snaps, as we saw also again in the previous lesson. We talked about the snaps, and then we have also other tools here. We're gonna see some more in this video. And if you don't see it, you can go here and expand these toolbars, or you can right click and open up the toolbars from here. So 2D and 3D are strictly related in FreeCAD, but also in other software. And I want to do some example in this lesson. I want to show you how you can import raster graphics, SVG, which means scalable vector graphics, and then CAD files or computer-aided design files. So raster graphics is just another way to call what is called pixel graphics. So it's a graphics made out of pixels, which is little tiny squares that compose an image and that can give a really realistic look to the image. Now, unfortunately, this is not really handy in 3D, but we need to convert this in scalable vector graphics or vector graphics more in general. And we can see the difference. So vector graphics are essentially neat and defined, and you can scale them, upsize, downsize every time, anytime. They will never lose quality. And you can also use it for 3D purposes or for other graphic design purposes. So there is a process which is called vectorizing or tracing, and it's basically tracing the lines in the pixel image and make them vectors. So this process is used, for example, in architecture. So if we have a plan view of an apartment or any other architectural project or a building in general, this is the Barcelona pavilion right here that we can find if we look for like free plan view or whatever. So you can do this in architecture. You can do this also in product design. So if we go like here and say product design, we can find some examples eventually. So free, let's say top side product design, and well, yeah, you can see some blueprints right here somewhere. But essentially, this is a process we usually do when we want to go from a scannerized image, something from raster graphics or pixels, and we want to make them vector graphics or CAD or computer-aided design graphics so we can work on them. So SVG means scalable vector graphics, and we can also look for free SVG on the web, and also we will see CAD. So CAD files can be found in DWG format or DXF, and we're going to use DXF because it's more compatible. And for example, this one here is plan view, but you can also find products or furniture or blocks, also they are called, so you can download them and put them directly in FREECAD and work with them. So before we're getting into some examples here that I will show you later, also, by the way, SVG can be used for graphic design and not only for product design or CAD. They're usually like universal. They use for many purposes, so also illustration and things like that. So I want to clarify and distinguish these three different types of graphics, we can call them. So raster is like more photographic and made with pixels. SVG is scalable vector graphics, and it can be used for anything, but usually is used for graphic design, and we can also use it for product. And then we have CAD, which is mainly used for architecture and design, so it's a more specific use, and it's another type of vector graphics in a way. So these two are vector graphics. This one here is made of pixels. Now to start, I want to use a graphic in raster, so with pixel. So I'm gonna do a search here and type free architectural plan view. We're gonna use an architectural plan view just as an example. And we have some really old plan views right here, which is perfect to explain the way we're gonna turn this into vector graphics. So I search for here Creative Commons licenses. So this is one example of a really basic plan view, but also this one here, like it's older and created probably hand drawn, created with pencils and things like that, which is fine. So this comes from raw pixels, and but we find also others. So let's go for this, and it's public domain image, so it's perfect. We can just free download. We don't need high resolution. Well, usually yes, we need high resolution, but for this example, I'm going to go for the low resolution. And this has also some measures which are good when you are trying to recreate something in vector graphics. Otherwise, you need to guess what the size are. Now, just as the same process, we can use, again, like for products or objects, you can use also more than one reference image. This time I'm going to use one reference, but you can also use more. And these are some examples of objects seen from different angles or projections or elevations. So like blueprints, as I was saying before. Okay, so let's get back here, and I'm gonna just close this and create a new one. So I'm gonna close and start again with a 2D draft interface. I'm gonna save this as lesson 09 and import. So how do we import an image? Well, it's basically the same process that we use. So we can go here to File, Import, and just navigate into the folder. I saved my image into this folder right here, among other, you see here, assets. So I want to use this one and open. So there you go. Now that we have the image inside, you can see it's selectable from the hierarchy list. So I can select it. And one thing we can directly change is the opacity. So if I right click here, we can say that we want to toggle the transparency. So it's going to be transparent, and it's going to be better when we're going to trace on top of this, when we're going to draw on top of this. So now that we have this, we can just start with a line and start to draw. So this is just a simple line, but I can, let me select it. Okay, so I can now delete it. Okay, and I can make a polyline, or I can make a rectangle, etc., etc. So the challenge is to follow as close as we can the pixels. It's really difficult because this is not a high quality image. So if I zoom in, I can see the pixel. I can be more precise. Still, there's going to be a lot of approximation here. I need to approximate and guess. Now, sometimes things are simpler. Like for example, if this is a pillar, I can just create a box, a square, essentially. That's going to be already closed, so I can then extrude it really easily. And also we have the sketcher interface or sketcher workbench. So also here